Hello and welcome. This presentation covers a group Capstone project on customer churn for a telecommunications company. This is important because customer churn is one of the most critical challenges for service providers, particularly in industries with high churn rates. A loss of customers affects revenue stream and increase competition from rival businesses. Therefore, predicting and managing churn effectively can significantly enhance company's performance and profitability. The primary objective of this project is to create predictive models based on historical customer data which is provided. By leveraging machine learning algorithms, the goal is to identify customers who have a high probability of churning accurately. These insights can empower the business to improve retention strategies that reduce churn and foster long-term customer loyalty. This project aims to demonstrate how data-driven decision-making can directly translate into better business outcomes using supervised machine learning algorithms. The dataset provided for this project contains features for customer information, including demographics, subscription details, service usage patterns, and billing records. The central task is to predict the target variable labeled as churn, where 1 indicates that the customer churned and 0 indicates that they did not. To accomplish this, we employ a range of supervised machine learning algorithms such as Perceptron, Logistic Regression, Support Vector Machines or SVM, Decision Trees, K-nearest neighbors or KNN, and Random Forest. The performance of these models is evaluated using the AUC-ROC score with the goal of surpassing a benchmark score of 82%. The AUC-ROC score, area under the receiver operating characteristics curve, is a widely used metric to evaluate the performance of binary classification models. It measures the model's ability to distinguish between the two classes, with the scores ranging from 0 to 1. A score of 1 indicates a perfect classifier with flawless distinction between classes. A score of 0.5 reflects performance equivalent to random guessing. A score below 0.5 suggests the model performs worse than random guessing. Before we dive into model training, several preparatory steps including exploratory data analysis (EDA) and data preprocessing are undertaken. We use Python as our programming language, harnessing libraries such as Pandas and NumPy for data manipulation, Matplotlib and Seaborn for creating insightful visualizations, while using scikit-learn for machine learning algorithms. To begin, the training dataset is imported into Pandas data frame. The setOption method was used to display all columns, followed by the head method to verify successful data import. The dataset contains 5,634 rows and 2-in-1 columns, as confirmed by the shape method. The describe method provides a statistical summary, offering valuable insights into key numerical columns in the dataset. The senior citizen column is binary, with value of 1 for senior citizens and 0 for non-senior citizens. Here we notice that 75% of customers are non-senior citizens. The tenure column indicates subscription in months, ranging from 0 to 72, with a median value of 29. Monthly charges average approximately $64, ranging from $18 to $118. The information method confirms the existence of known null values in the dataset, but the total charges column, stored as an object, requires conversion to a numeric format. Going to data visualization, to identify a relationship between features and churn, we create a reusable function for plotting bar charts. The visualizations reveal the following. Plotting the target variable with the pie chart indicates that 73% of customers did not churn, while 27% did. This imbalance in the class distribution would affect machine learning models, leading to bias towards the majority. And looking at the bar chart, the churn rate for male and female customers are similar, suggesting that gender might not be a strong predictor. Senior citizens had a higher churn rate than non-senior citizens, making this feature potentially critical. Customers without partners or dependents exhibited high churn rate, while shorter tenure correlates strongly with high churn rates, emphasizing its predictive value. Features like internet service types, online security, and tech support significantly influenced churn probabilities. For instance, customers with fiber optic internet or without online security had high churn rates. Customers with month-to-month contracts had the highest churn rate, whereas 1 and 2 year contracts exhibited excellent customer retention. Looking at payment methods, customers using electronic checks showed higher churn rate than other payment methods. Moving on to the distribution of monthly charge versus churn, we observed that many customers have very low monthly charge, around $20, and the customers paying rates between 70 and 100 showed a high churn rate. However, the churn rate gradually declines for monthly charges ranging from 110 to 120. This indicates a strong correlation between monthly charges and churn rate, making this feature critical for predicting customer churn. Now moving on to the data processing, where we prepare data for machine learning involving several steps such as feature removal. Here we remove irrelevant features like customer ID and handle missing values. The total charge column contains 8 missing values, which is replaced with the mean. We then move on to encoding categorical features using one-hot encoding, which is applied to transform categorical data into binary features. Then moving on to feature and target separation, features X and the target variable Y were separated, and the data set was split into training and test sets using an 80-20 rule. Stratified sampling ensured that the class distribution remained consistent across splits, and this is shown in the bar chart. Feature scaling standardization was performed using standard scalar to ensure that all features had a 0 mean and a standard deviation of 1. Moving to model training and evaluation, each classifier was trained and evaluated using classification metrics such as accuracy, precision, recall, F1 score, and AUC-ROC score. The performance of various classifiers was evaluated using the AUC-ROC metrics. Looking at the Perceptron model, the baseline AUC score was 76%. After applying hyperparameter tuning using random search from the scikit-learn library, it did not yield significant improvements. For the logistic regression, the model achieved a baseline AUC-ROC score of 83%. After tuning, the score remained stable, affirming its reliability. Looking at the SVM, the baseline AUC-ROC score was 81, and tuning resulted in a slight improvement, raising the score to 82%. And in the case of decision trees, starting with the baseline score of AUC-ROC score of 71, tuning brought a noticeable enhancement, increasing the score to 76%. For the k nearest neighbor, the model baseline AUC-ROC score of 75%, which improved significantly to 80% after tuning. Random forest with a baseline AUC score of 82, this model secured its position as the top performer by achieving a tuned AUC-ROC score of 83. Moving on to model comparison, performance metrics, the tuned models were compared using a horizontal grouped bar chart, and some key findings include random forest emerged as the best performer algorithm, surpassing the benchmark score. Logistic regression closely followed, while Perceptron consistently underperformed across all metrics. After cross-validation, 4 out of the 6 logistic regression, SVM, KNN, and random forest exceeded the benchmark and have shorter error bars representing the standard deviation of the AUC-ROC score, showing consistent performance across the validation faults. The models, Perceptron and Decision Tree, fall short of the benchmark and have long error bars, showing inconsistent performance across the validation faults. Random Forest achieves the highest mean AUC-ROC score, followed by Logistic Regression and SVM. Perceptron is the lowest performer. In summary, tenfold cross-validation confirmed Random Forest as the most reliable model with a mean AUC-ROC score of 84.7%. Logistic Regression and SVM also performed well, exceeding the benchmark. Now, moving on to the test data. After selecting the Random Forest algorithm as the final model based on the comparison metrics, we performed similar pre-processing steps on the test data as we did on the training dataset. First, less informative features such as the ID column are removed. The total charge column is converted to numeric format, and missing values are replaced with the column's mean. Categorical features are then encoded using the getDummies method from the Panda library. Feature scaling is applied to standardize the test data. Next, class level predictions are made using the selected base model, here Random Forest, on the standardized test data set. Predictive probabilities for the positive class 1, which is churn, are also calculated. Finally, a submission file is created containing the IDs and their corresponding predictive probabilities, which is saved using the toCSV method. Based on the insights gained from the EDA, the following recommendations can be made. Customers with short-term subscription durations are more likely to churn. A solution would be proactively addressing customer complaints and improving service quality to enhance retention. Coming to highly monthly charges, higher bills are associated with a greater likelihood of churn. So one solution would be providing discounts or incentives to customers with high monthly charges to encourage continued service usage. Looking at contract types, month-to-month contracts have significantly higher churn rates compared to long-term agreements. One solution would be to offer discounts or incentives to encourage customers on month-to-month contracts to switch to long-term agreements. Other issues we can notice from the EDA is a lack of additional services, where customers who do not subscribe to bundled services such as internet or streaming are more likely to churn. One solution would be promoting bundled services as a package to provide greater value and reduce churn rate. In conclusion, Random Forest has been identified as the optimal model for churn prediction for the telecommunication company. Predictive insight derived from this model enable the company to develop targeted retention strategies, enhancing customer satisfaction while reducing churn rates and increasing revenue. This project demonstrates the potential of machine learning in addressing churn rates within the telecommunication industry. Thank you.